There you go. Anyway, so we had kind of a cloudy weekend. Got to see a little bit of sun Sunday, Saturday afternoon, and a little bit Sunday morning. But we're also going to definitely get rain tomorrow. And then I think starting maybe around Wednesday, Thursday for sure, we might have 5 days in a row. Nice sunny, cool weather, something like that. So hope you're doing well. Welcome back, everybody who was gone on Friday. We went over a test on Friday. Is that correct? Okay. And I showed you the statistics. Did we do that? Okay. I have stats if you want to see the stats. Like how'd you do compared to everybody else? And the only reason I do that is actually to motivate you. If you saw your initials on there, you said, I kind of like that. I kind of like that. And you might say, that's my goal. I'm going to get my initials on. I got an A on that test, and I have my initials on there. If you felt like, well, I really wasn't where I should have been. I look on there and say, I don't think I should have been. That's going to motivate me to do better on the next test, okay? And everybody's going to have, not everybody, but a lot of people are going to have some tests they do better on than others. But that's not the only thing we do in here. We did a lot of other things besides that. So that's not their only grade. But I do want you to do well on the test. The test shows me how well you're retaining information. Are you taking it with you? Okay, so that's that. Tomorrow is Spirit Day. Don't forget that Blue and Gold Day, and we get to play Westchester in volleyball, Westchester, and we play soccer, play Westchester, don't we? Even though it's supposed to rain. And I think tennis plays Westchester, right? So anyway, that's Blue and Gold Day tomorrow. What else is there? Okay, so what we're going to do is everything kind of changes now. When I didn't used to teach chemistry exactly like this, but I felt like I started doing this many years ago, over 20 years ago. I wanted you to start out, and almost from the beginning, you actually learned elements, didn't you? So you already got a little bit into some of the chemical elements. And then you also started doing the scientific method. I wanted you to be in the lab right away. And I wanted you to maybe even do the scientific method and come up with some of your own little experiments. I wanted you to do that. And I wanted you to experience that. Now we actually are changing course now. What you're going to find out is Chapter 2 is really completely different than what you've been doing. You got that? So Chapter 2 is completely different. If you did very well on Chapter 1, or the first test, I should say, I'm really glad. And you guys did do well. What I want to caution you a little bit about is the next test has a lot more to do with numbers. Okay? There will be words. There will always be vocabulary words. But it'll have more to do with the idea of numbers. The chapter is called Measurement. Measurement is the heart of the science. The science experiments, it's the heart of it. How do you discover things in science? You usually measure things and they change. And you figure out what that change means. So measurement will always be the heart of chemistry and physics and all those things. So that's what this chapter is about. And it has a great deal to do with numbers. Now, like I said, some of you will find this chapter to be, you really like it even better because you like numbers. But some of you are going to have to work a little harder on this chapter because it does have to do with numbers, all right? Are you guys, what kind of math are you in right now? Pre-calc. Okay, that's fine. I mean, you're in algebra, probably algebra 2 though, isn't it? So you're way up there. You're in honors algebra. That's up there. And pre-calc's up there. So I'm not doing anything like that. I'm nowhere close to that level at all. Okay? So what I'm going to do is I'm going to give you a sheet, and you're going to find that almost every chapter I give you some kind of a packet that I use to teach with. Let's see. What you guys do this time? And so what I'll do is this chapter will be over it won't last as long like the first test did. And so it'll be just Chapter 2 and this packet. And so you'll see that I don't think we'll be done by the end of next week, probably. By the end of next week. Very nice. Yeah, you can get some right there. Okay. Now, is this so that I don't pick you again then?
No, you just wanted another one.
Good strategy.
He just wants to learn everything twice.
Did you give her the nerve one?
No, I'll put it on the
All
bottom.
right, all right.
He said this was
Okay. All right, so, the first thing I'm gonna do is, I wanna tell you about, how things are gonna change as far as the book. Now, if you happen to have the book with you, the book with you right now, let's go to chapter 2. And once you look on the first page, you'll see where it actually is about the measurement. Now, there may only be one other chapter all year that I have you take notes on, all right? So, anyway, this one's on measurement, and if you leaf through it, just kind of leaf through the chapter, you'll see some numbers, you'll see some vocabulary words, you'll see something that looks like the metric system. Keep looking, just kind of leaf through it, go all the way through it. Well, it looks like math, it's a little bit different. Now, I will tell you, for example, that the author gives you a lot of example problems in this chapter, and I think that's what makes the chapter look long, okay? It makes it look long. He teaches, I think last time I counted it was 6.5 or 7 pages teaching you how to change from one temperature scale to another. I will be teaching that in class in about 15 minutes. So even though he takes 7 pages, it's because he wants you to do a lot of examples. Okay, now let's go back to the end of the chapter, and this is where things change a little bit. Okay, let's go to the end of the chapter. Okay, hang on, I'll tell you what we're doing. At the end of the chapter, you'll see a section, the very, very first section is probably called summary and then active learning questions. We don't do those. If I wanted to, if I had 5 days a week, I might consider that. But go to the section where it says questions and problems. Okay, go to the section called questions and problems. All right, if from now on, for the rest of the year, whoops. I'll get that man. If I ask you to do the problems at the end of the chapter, here's how we do it. Somebody last year should have had your book, and they should have made a little note and say, start here. See where it says questions and problems? And then they should have made another little note that says odd. You only do the odd questions. If you don't see that, you have my permission to write in that book. Now, what we do is, if I ask you to do the odd questions, then that's the ones you turn in. But if you'll take a look at question number 13, look at 13. How many parts does question 13 have? Quite a few, doesn't it? What I require is 4. So if you see that there were 8, you only have to do any 4 you want. Now the way I do this is that at any time, if you are working on homework, and you said, I just spent 30 minutes last night on homework, but I wanted to check to see if they were right. I have a teacher's edition. And all you do is put your paper next to the teacher's edition, you check it. And that's up to you. If you want to check them for accuracy, then that's what you do. And you can do that anytime. It could be before school, lunch, after school. I'll say, here's the teacher's edition, you check it. Got it? Okay, so it's not my job to see if they're accurate. I'm going to teach some material. If you want to check for accuracy, that's up to you. Now, when I grade it, I will have you eventually count the ones you did. Somebody will count them. I'll say, how many questions did you see them do? And they'll count them. And let's say, for example, this one might be like 84. It's possible there are like 84 things you have to write down. And so we'll count them, and then I will look at every page to see if you showed your work like that, and then I will give you credit based on that. So you're really getting credit for doing it, and I know that if you do it, and you listen in class, you're going to do well in here. So, but I don't actually take a whole day and give you all the answers and things like that. I don't do that. Okay, questions on that. Now, when do you stop? How far do you go on this? Now, they should have written the word stop where it says additional problems. So you don't have to go to additional problems. You get that? So they should have done that. Now, I have some more good news for you. There's a section on page 49. There's a section called 2.6. 2.6. Everybody see that? Now, we're not going to do that in this chapter. You'll say, oh, I know why. It must not be very important. Just the opposite. 2-6 is really, really important. So why am I not going to do it? Because this chapter has so much stuff in it. It has so much stuff in it that I don't want that to get buried into all that stuff. It just so happens that chapter 3 is a very short chapter. So what I'm going to do is teach the 2.6, but chapter 3, very important, okay? So I don't want you to do the questions for 2-6. Now, if you don't write that in there, you're going to spend a lot of extra time you don't have to do. Everybody got that? You there? Okay. All right. All right, questions. So if I ever say, let's do the odd questions for homework, and these are always due the day of the test. There's no way we're going to test this week. If we do test, it would be the end. It would be the end of next week. We got almost 2 weeks, right? So you're okay. All right, questions on that? Now, I want to show you something we're going to be doing. You could start reading the chapter tonight. You could, and you already read it. You said you already definitely started, right? You read it. I'm going to teach a little bit differently than the author, but I do want you to read through there because there's vocabulary words and stuff like that. You're responsible for vocabulary words. Will I use those words? Yep, I'll use them. So there will be a section with vocabulary words in the next test, but most of it will be about numbers. Got that? All right, I'm about ready to start. Are you ready? All right, so let's see if we can do it. I'm going to be teaching a little bit differently than the author does. And if you wanted to wait a little bit before you did the questions, that might actually help. The lesson I give today and the one I give on Wednesday will give you a great deal of help doing this. All right, ready? So what I'm going to do is I'm going to show you this chart. And have you ever seen this before? I'm looking at your faces, and some of you say yes, some of you say no. This chart, if you will allow me to show you the ins and outs of this chart, I can teach you a lot of things in this chapter. This chart has a lot to do with the metric system. This chart has a lot to do with scientific notation. And if you learn this chart, you'll see that teaching that other stuff is really easy. I will not teach scientific notation the way the book does. Because the way the book does it, it's the way your math teacher does it. You say, well, what's wrong with that? And I'll even tell you later what I think's wrong with the way that they do it. Okay? The way they do it in the book and the way your math teacher does it is a very concrete way of doing it. And if you remember the 3 steps to put a number into scientific notation, and if you remember the 3 steps to take them out, then you can do that as long as you don't mess up your memory. And then a year from now or a month from now, you'll forget it. I'm going to try to teach it so that it makes so much sense to you, you'll never forget it. You'll never forget how to do scientific notation. So we're going to see if this works, all right? So let's start with, we're just calling some people. And, let's all I want to do is explore. Let's explore this chart and find out what the kind of patterns there are, okay? Okay, how about John? You ready? You can do it, John. Now, I know you have I know you have a mask on, right? Right? Okay, here we go. How many of these does it take to make one of those? Say it real loud.
10.
How many of these to make one of those?
100.
How many of these to make one of those?
1,000.
Okay. And one more time. How many of these to make one of those?
10.
Okay. How many of these to make one of those? Let's start again.
1,000.
How many of these to make one of those? Now everybody stay with me, okay?
10.
How many of these make one of those? How many of these make one of those? How many of these make one of those? How many of these take to make one of those? Let's start again. How many of these it take to make one of those? How many of these to make one of those? How many of these to make one of those? How many of these to make one of those? How many milligrams does it take to make a centigram? How many milligrams to make a decigram? How many milligrams to make a gram? How many millimeters to make a centimeter? How many millimeters to make a decimeter? How many millimeters to make a meter? Okay, now I just asked you a series of questions. You see that? And I don't think your teachers teach that way. I don't think they teach that way. But this chart, even when they made the metric system, they said, they did something no one else had ever done. They said, we're going to base it on something that every human on the planet uses anyway. There's a concept here that every human uses. Everybody on the planet uses the same number system, don't they? And the number system that you use is what they call the decimal number system. It's based on powers of 10. Now, powers of 10 are not multiples of 10. Multiples of 10 are 10, 20, 30, 40, 50. This is not the same ballpark. These are powers of 10, like exponents. 10 to the first, like 10, like 1, 10, 100, 1,000, 10,000. Everybody get that? Okay, these are called powers of 10. All right, let's go to, let's see somebody else. Caroline. This Caroline. Ready? See if you're paying attention. How many of these does it take to make one of those?
10,
How many of these make one of those?
100,
How many of these make one of those?
1,000,
How many of these to make one of those?
10,
How many dimes to make $1?
10,
How many dimes to make a $10 bill?
100,
How many dimes to make a $100 bill?
1,000,
Okay. All right. How many of these to make one of those? How many of these to make one of those?
10,000,
Try it again. How many of these to make one of those?
10,
How many of these to make one of those? Huh? No one's ever asked you that question, have they? It's, I understand all of you are good students, right? You're all good students, and when a teacher asks you a question, you think, it's probably there somewhere, and I can actually look at your eyes and tell what's going on. If you stay with me and you see the pattern, your eyes will stay focused right there. But if you go like this, it means you're looking for something in the past. You said, I think I'm supposed to know this. Let's try it again. How many of these to make one of those? How many of these to make one of those?
10,000,
How many of these to make one of those?
10,
How many of these to make one of those?
100,
No, how many of these to make one of those?
10,
Let's try it again. How many of these to make one of those?
10,
10? Yeah, how many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many of these to make one of those? How many of these to make one of those?
10,
All right. How many of these to make one of those? How many?
10,
Yes. How many of these to make one of those?
100,
How many of these to make one of those?
1,000,
How many microliters does it take to make a milliliter?
1,000,
That's right. How many micrometers does it make to make a liter?
100,000,
Almost. It's 10, 100, 1,000, 10,000, 100,000, a million. Everybody with me? Now, I'm asking questions that no one has ever asked you before. Some of them have, but nobody's ever asked you that before, right? All right, Jonathan, ready? Jonathan, how many of these does it take to make one of those? How many of these to make one of those? How many of these to make one of those? Okay. How many of these does it take to make one of those? How many of these is this? How many of these to make one of those? How many nanometers to make a micrometer? How many? No? How many? Okay, how many of these does it take to make one of those? How many of these to make one of those? Wait, this is 10. This is 100. How many of these to make one of those? Let's try it again. How many of these to make one of those? How many of these to make one of those? How many of these to make one of those? How many nanometers does it take to make a micrometer? Everybody see that? How many nanojoules does it take to make a microjoule? What's a joule? Say, I don't know, but it doesn't matter. You're right, it doesn't matter. And that's another thing that's kind of neat. A lot of people get messed up, and I think the way they try to teach the metric system in elementary and middle school, I think it's kind of wrong. They said, well, let's talk about distances. And they talk about a meter and a centimeter and a millimeter and then a kilometer, and they get you all messed, and they get you all okay on that. Now we're going to talk about mass. And they talk about grams and kilograms, see that? And then we're going to talk about volumes. Yet, if they could show you this right here, watch this, now watch. How many of these does it take to make one of those? 10. How many of these to make one of those? 100. How many of these make one of those? 1,000. Watch. How many millimeters does it take to make a centimeter? 10. How many millimeters to make a decimeter? 100. How many millimeters to make a meter? How many milliliters to make a centiliter? How many milliliters to make a deciliter? And how many milliliters to make a liter? It's the same question, isn't it? How many millijoules to make a joule? Whatever a joule is, the answer is what? It's 1,000. Now, if I can get you to relax and see the pattern there, then you'll see where everything falls into place a little bit. Now let's go on, Lacey, ready? Are you ready? Sort of. Okay, ready? How many of these does it take to make one of those? How many of these make one of those? Okay, now I'm going to ask you some hard questions. You got it? A little bit harder. How many of these does it take to make one of those? How many of these does it take to make one of those? And this question is way above the other questions. So what do you think? I give you here, how many of these does it take to make one of those? How many of these does it take to make one of those? Yes. Way to stay with it. How many of these does it take to make one of those? How many of these to make one of those? Yes. And how many of these to make one of those? Yes. See, we're still in powers of 10. Does everybody see that? Let's go over here now. You did a good job. Even though I know you guys are in higher math, there's some things you do know and sometimes you don't. I don't know which you know, which you don't know. And also, I think sometimes when you get out of math class, you don't transfer. Sometimes you don't transfer things in math. And for whatever reason, I don't think I ever had a math teacher or science teacher, or math, I should say, that transferred some of that stuff to my science. And I was ashamed because it should have been there. Look at these over here. Everybody see these? And you know that. You know that 10 to the 0 is 1. As a matter of fact, you know that anything to the 0 power is 1. Isn't that right? Even A. What's A to the 0? 1. What is 5 to the 0? It's 1. And you picked that up, didn't you? And so 10 to the 0 must be 1. Now, what you look up here is, you say 10, and when you were really young, and the very first teacher that taught you about exponents said, well, write the number down 10 one time. Okay, 10 to the first is 10. Another teacher said, well, 10 to the second, you get to write the number 10 down twice and multiply them. This is like 10 times 10. And that may be how they taught you what that meant. And they might have said 100 is 10 times 10, or it's 10 to the second power. And then I felt grown up when they said, that's sometimes called 10 squared. Oh, yeah, 10 squared is same as 10 to the second power, isn't it? It means 10 times 10. And 10 to the third is 10 times 10 times 10. That's 1,000, isn't it? Did they teach you something like that? No? They taught it differently than that? Did you know that 10 to the third was 1,000? Okay. All right. Let me ask you this question. I bet they didn't ask this question before. How many 3s are in 10 to the third? What do you think? How many 3s are in 10 to the third? None. That's 10 to the third. There's no 3s. And so, for the first time ever, the number 3 didn't really mean 3. 10 to the third does not mean 3 of anything. But it does mean this. And when you were in the 4th grade, they had this page, and they had a big old fat decimal point. And they had a little place here, and they had a place here, and they had a place here, and they called them, what do they call those things? Place values. And here, this was called the ones place. That's interesting. This was called the tens place, the hundreds place, and the thousands place. Now, you were too young for them to teach this to you, but here's what they meant. This is 10 to the zeros place. This is 10 to the first, 10 to the second, 10 to the third. That's what they meant, but you were too young for them to teach that to you, so they just had you memorize ones place, tens place, hundreds place. See that? Now, if you understand what I just said here, 10 to the third is actually 1,000, isn't it? But then you go down here and you see these numbers here. And you had to do something because in your mind, whoever taught you negative numbers, I don't know what age you were, this right here, for example, what is 10 to the minus 3? Well, there's another little math trick that most math teachers teach. Let's try that. 1 over x to the minus 4th. And now, I don't know about you, but I think a lot of the math teachers at this school say something about that. If you turn this in as an answer, what do they tell you? What do they say? It's wrong? It's not wrong. That is the correct answer, but they want you to not have negative exponents in the denominator. Is that right? Or maybe no negative exponents. Is that correct? It's one of those. Okay, now this is not wrong. They just said, I just don't want to see negative exponents. And so they probably taught you some little trick like this. If you take something in the denominator and throw it up here in the numerator, you're going to pay a price for that. And the price you pay is you have to change the sign of the exponent. And so that's the same. This is that. And I wish somebody would have taught that to me earlier. But look at this. What if I go the other way? What if I want this to be in the denominator? I just pay a price. 1 over x to the minus 4th. See that? And so maybe that math teacher did something like this. X to the minus 3, y to the second, z to the minus 4, over x to the third, no, x to the fourth, y to the minus 1, z to the third, okay? You ever seen that? They love doing those kind of problems, okay? And so maybe the math teacher showed you some real fast way of doing that, and they said, ready? Take this down, see? See a negative exponent? Take it down. And it's going to be what? X to the what? X to the third. Isn't that right? It is. Okay, and then take this up. Take that up. That's going to become y to the 1. And take that down. It's going to become z to the 4th, because that's the price you pay, right? And what's the final answer? When you multiply numbers with exponents, you add the exponents. So it would be y to the 3rd over x to the 7th times z to the 7th. See that? And it probably did something like that. Well, what I'm here to tell you is, when you see this right here, 10 to the minus 3, again, how many 3's are in that number? None. How many negative 3's are in that number? None. It does not mean negative 3. It does mean this. 10 to the minus 3 is the same as 1 over 10 to the third, isn't that right? But that is the same as 1 over 1,000 because 10 to the third is 1,000. But 1 over 1,000 is the same as 0.001. Now, watch. What kind of number is 10 to the minus 3? Positive or negative? And you have to fight this. You have to fight it because 10 to the minus 3 is that number. That is not a negative number. It's a decimal number. So when you say 10 to the minus 3, don't think negative number. Think decimal number. Now let's look for some more patterns, okay? Look for patterns. I had to know that 10 to the third is 1,000. What was 10 to the minus third? 1,000. And 10 to the sixth is 1,000,000. So 10 to the minus 6 would be, oh, I like this. and 10 to the ninth is a billion, and 10 to the minus ninth is a billionth, and 10 to the 12th is a trillion, 10 to the minus 12 is a trillion. That's pretty nice, isn't it? Everybody got that? I like that pattern. Let's look for some more patterns. 10 to the third has 3 zeros. 10 to the sixth has 6 zeros. 10 to the ninth has 9 zeros, and 10 to the 12th has 12 zeros. I like that too. So if somebody say, write the number 10 to the 12th out, you say 1 and 12 zeros. Ready? 10 to the third has 3 zeros. 10 to the minus third has only 2. Make up your own memory trick.
Mr. Beatty?
Hello. Okay, thanks. Give it a point. Okay, so, all right. One more time. 10 to the third has 3 zeros. 10 to the minus third has what? Only 2. All right. 10 to the 6 has 6 zeros. 10 to the minus 6 has 5. If you had to write out the number 1 billionth, how would you write it? Decimal point?
8 zeros.
8 zeros and a 1. Right, got that? Now again, I'm trying to teach you some patterns. The more patterns I can teach you, then you can learn this chart very easily. All right, questions? Looking around here. All right, we're looking for patterns, all right? Okay, let's try this. What can I call on? Let's see. Madeline, ready? Ready? How many of these does it take to make one of those? How many of these make one of those? How many of these make one of those? Okay, now, how many of these to make one of those? Now, I'll give you a clue. How many of these does it take to make one of those? How many of these to make one of those? 10. How many of these to make one of those? 100. How many of these to make one of those? Now watch real carefully. Watch now. See 0, 10 to the third? There's 3 powers of 10 that separate them, right? What is 10 to the third? All right. How many of these does it take to make one of those? Now you could do it this way. You could say 10, 100, 1,000, 10,000, 100,000, million. You could. But we can do something a little faster. How many of these to make one of those? How many powers of 10 separate them? How many? How many powers of 10 separate 10 to the 0 from 10 to the 6? It's bigger than 5 and less than 7. 6. How many powers of 10 separate them? 6. How many of these does it take to make one of those? Don't say 6, but say 10 to the 6th. And what is 10 to the 6th? A million. Now let's try this down here, okay? This is the hardest question I've asked you here, so ready? How many of these does it take to make one of those? Now you could do the slow way and say 10, 100, 1,000. Or how many powers of 10 separate these two? 3. What is 10 to the third? It's 1,000. Ready? How many of these does it take to make one of those? Yes. I'm looking at your faces. You got to help me out here, okay? If that's making sense to you, you can do these a lot faster, can't you? One more. How many millionaires would it take to equal the money of a billionaire? All right, that's all right. That's all right. I was calling on her, but that's all right. What'd you say? How many millionaires take to equal the money of a billionaire? 1,000. You know, if I took all the tables out of here, and let's say everybody knew a millionaire, and they had exactly $1 million, and I had them stand up here, it's possible I could get about 60 or 70 millionaires in here without the desk. But how many millionaires equal the money of a billionaire? I could pack this room and pack that room and that one and that one and that one and that one and that one. What? And then I might be able to have the money of a billionaire. A billionaire is not the same as a millionaire. what's scary is to know what the national debt is. The national debt is over $20 trillion. I don't think you understand. As a matter of fact, as smart as you think you are, I don't think anybody in this classroom actually understands what a trillion is. You can write it, you can do calculations with it. I don't think you understand how much a trillion is. It's what? If you thought you knew what a million was, right? If you thought a million's a lot. Matter of fact, that's hard to understand what a million of anything is, isn't it? I need 1,000 million to equal a billion. I need a million to equal a trillion. A million millions is a trillion.
We've got 20 of those.
Okay, 20 times that. But anyway, don't worry about it. Something's going to happen. Something. Well, we don't know. We'll see. Something will happen. Okay, so what I'd like you to do is, if I'm going to use this as a tool to teach you things, let me start making a little tool out of it. And we're going to learn these little prefixes, all right? Now, a lot of these you may have had in middle school, and as a matter of fact, they probably start in elementary. If I had to guess, elementary, they try to teach these 6. If I had to guess, they probably go a little bit bigger in middle school. Maybe, okay? I'm going to go, the highest I'm going to go here is a trillion, and I'll go down to a trillionth. If I were to ask a bonus question, it would be these 2. But I usually don't have 10th graders learn that. They're not required to learn it, but if you want to learn it, it might be a bonus question like that. All right, let me show you how to memorize these prefixes, and then we're going to move on a little bit. I'm going to start all the way up here at the top, and my memory trick for this is tera, trillion, 12. See that? Tera, trillion, 12, 10 to the 12. Now, that's alliteration, isn't it? Tera, trillion, 12. If I can remember tera. You guys, believe it or not, in my generation, nobody had a home computer. And then, as I got a little older, somebody in my neighborhood had this thing called the Commodore 64. And the Commodore 64 would be worth a lot of money now because it's antique. But the first home computer was 64K. It had so little storage capacity, it only could store 64,000 bits of information. It was at least a home computer, but it had a cassette tape. The cassette tape had the operating instructions on it. You had to put the cassette tape into it, and then you could run the computer. And it would store 64K. And then I remember that later they came out with the 128, and then the 256. And then they went all the way up to, I couldn't believe it. In my lifetime, I saw somebody had a megabyte computer. That was unbelievable. And yet, every time you take a picture with your phone, it's probably about 1 megabyte. That's unbelievable. And now, your generation, you're living in I got an iPhone. Well, you want the 32? You want the 32 gigs, or you want the 64 gigs? Okay, well, I take a lot of pictures and things like that. I want 64. Well, anyway, so your generation is easily into the gigabyte realm, and I bet some of you, either you or your parents or somebody you know, has a terabyte computer. Now, these are people that probably play lots of games. They're a gaming person. They have huge amounts of movies and stuff like that. And do you have a gigabyte storage? Do you have a gigabyte computer? Terabyte? Wow. Okay, see, you guys are at the realm of this, and not too long from that, you'll be the petabyte. The petabyte computer will come after that. Anybody here on that? Nobody's here on that. Okay. All right, here we go down. Ready? Tera, trillion, 12. I don't have a good one for giga. I don't have a good memory trick for that, but I will. It is gigantic. It's gigantic. Yeah, and that's my memory trick there. As a matter of fact, the original pronunciation was giga. And if you watch Back to the Future, the original movie, you'll say 1.21 gigawatts, and everybody laughs. They go, oh, you made that up. No, he didn't. It really was pronounced gigawatt, but the computer industry was not going to call it giga. They're going to call it giga. And when they say giga, that's what it's going to be from now on. All right, mega. I don't agree with this, but we have a lottery in North Carolina, and it's a Mega Millions, isn't it? Most people know Mega Millions. You okay with that one? Let's go down here, and this is the one they teach in middle school, and they probably have some cute little story like this. King Henry died drinking chocolate milk. And if they didn't have that, maybe they made another story or something like that. Did you have something like that? Oh, okay, here we go. So kilo, and by the way, take a look right here. Notice that if you're a million or bigger, you're so big, you have to use a capital letter for your abbreviation. So make that notation to yourself. If you're a million or bigger, you're going to use a capital letter for the abbreviation. But nothing below a million is capitalized as far as the abbreviation. Little k is kilo. Kilo means 1,000. Hecto, 100. Hecto, 100, little erration there. You have deca and deci, very similar. But a decade has 10 years in it, isn't it? I don't want anybody of my students saying, oh, I thought deci, a decade. No, why? Why are you still confusing the two? A decade has how many years? Well, then deca means 10. And this guy is the decimal number, isn't he? Deci is a tenth. Now look at the abbreviations. Well, the big guy gets the big abbreviation, didn't he? DA, that's deca. D, deci. A cent. A cent is 1/100th of a dollar. I get it. Centi, 1/100th of anything. Milli, 1,000th of anything. Now we go down here and we see this weird looking sign right there, and it says micro. Well, I do know it's so small you need a microscope to see it. At least I know that micro means really small, isn't it? And so we had already used the M by itself to mean meter. The M with a dash after it means I'm not a word, I'm not a noun, I'm a prefix. That's what that dash means. It means I'm a prefix. So M by itself means meter. M with a dash after it means milli, whatever. You have to put a word after me because a prefix can never stand alone. There's no such thing as a milli. You can have a milligram, a milliliter. You get that? Okay, next. Now, so I've already used this M, small m for meter. Small m with a dash is a prefix for milli. I already used capital M for mega. And now you want to use micro? We're running out of M's. What am I going to use for abbreviation for micro? Well, we'll go to another alphabet. And this is a mu, this Greek letter mu. And that's the way the typewriter does it. And the way you do it by hand is you make a little U, and then you put a tail in the front, and you make this noise. Whoop. Okay, let's try that. Ready? Make a U, put a tail in the front. Whoop. Okay, everybody try that? Now, so therefore, if I use the mu symbol, it means 1/1,000,000th of anything. Okay? Micrometer is 1/1,000,000th of a meter. Microliter, 1/1,000,000th of a liter. Next, nano, -9. That's my memory trick. Nano, -9. A billionth, isn't it? Little n. I'll come back to this guy in a minute. And pico is a trillionth. Little p, pico, a trillionth. All right, what do you think? Now, I need you to be comfortable with this chart. And I'm going to see how comfortable you are. I'm going to mention a number, and you tell me what power of 10 it is, okay? Or if I mention the power of 10, you tell me what number it is. It goes like this. 10 to the second. You say 100. I get that? All right, so get ready. Let's see how well you know this already. 10 to the 6th. A million. 10 to the -6th. All right. 10 to the 9th. 10 to the 12th. 10 to the 1st. Okay. 10 to the -3rd. Okay. Ready? 100,000. 100,000. Well, 1,000 is 10 to the third, right? 1,000 is 10 to the third. 10,000 10 to the fourth. 100,000 10 to the fifth. Ready? 100 billion. Very good. 10 to the 11th. 1/10 millionth. 1/10 millionth. What'd you say? Yes. If 10 to the minus 6 is a millionth, 1/10 millionth is 10 to the minus 7th. 100 billionth. 100 billionth. Wait. What is it? 100 billionth? 10 to the negative 11. Okay, everybody got that? So see if you can learn these powers of 10 really quickly like that. All right. I want to show you two more things on this side of the thing, and I do want you to learn these pretty fast. I've given you little memory tricks, so whatever you need to do to learn your prefixes, I want you to do that pretty quickly. But I'm going to show you a couple of stories here. It's down here, and anybody who's a science student need to know this story. Now up here on the chart, you'll see the mu symbol with a dash after it. If you see the mu symbol with a dash after it, that means the prefix micro, and whatever you put after that, it means a millionth of whatever it is. So a micro Snickers is a millionth of a Snicker bar. Now, if you go on down here, if you ever become a biologist, or you take advanced biology or something like that, you will see this symbol again, and it looks like this. You'll see a mu with no dash after it. Now, I wasn't around when I did this, but I do know that even when I was in college, I saw this a lot. When I was talking about the size of a bacteria, the size of a cell, it was in micrometers. And when they wrote it out, micrometers, and the word's like really long, micrometers. And then there was a transition. Some books stopped using micrometers, and they simply started using this by itself. And that means that they decided, the biologist said, you know what? You get tired of saying micrometers? Yeah, I think so. Why don't we just call it something else? Can we do that? Yeah, we can do that. And they said, I'm going to call this a micron. So if you ever heard the word micron, it's a distance unit, and it's the same as a micrometer. A micron is a micrometer. Okay, so now, if you ever look at anything in biology, and you see something small, and they say 10 microns, oh, you mean 10 micrometers, the same thing. But it's the mu symbol with no dash, and that means microns. Now, another group of people, they were measuring things that were even smaller than cells. And they said, we're going to measure small things. Well, what about nanometers? Well, not bad, but nanometers, we use a lot of them. Like it might be 80 nanometers or 800 nanometers. We need something a little bit smaller than a nanometer. So they said, I'm going to make up a name for something that's a 10 billionth of a meter stick. A 10 to the minus 10. 10 to the minus 10 meters, we're going to use that to measure the size of atoms. Some atoms, their diameters are 1 angstrom, 2.5 angstroms. And so they made this up. It's 10 to the minus 10 meters. 10 to the minus 10 meters is an angstrom. So an angstrom is a measurement unit that all scientists know, and it's a 10 billionth of a meter stick. And it's called an angstrom. How many angstroms does it take to make a nanometer? 10. 10 angstroms equals a nanometer. Anyway, everybody understand those two words? So if you see this with no dash after it, it means micron. If you see this is not a prefix, this is not a prefix. The mu symbol with no dash after it is not a prefix. It means micron. And if you see an A like that, and I've seen little A's in capital, they have a little circle over it like a halo. Used to be like the California Angels. What's the name of their team now? Used to be the California Angels, and it was LA Angels. What is it? Is it LA Angels now?
Yeah.
Okay. Anyway, they had different names. And anyway, they still have the A with a circle over it. Okay, all right. Maybe that's for angels. All right, what do you think? All right.